Today, we're going to talk about Dimitri Mendeleev. And yeah, I know what you're thinking. The periodic table, that chart from every science class ever. But trust me, his real story is way, way cooler than that. This isn't just about organizing stuff we already knew, it's about predicting the future.
So let me just ask you this. What if you could describe something in perfect detail? I'm talking its weight, its behavior, everything about it, before anyone had ever even seen it, before there was a single shred of proof it was real. Well, that's exactly what Mendeleev did. All right, so where does this crazy story start? It starts with the most revolutionary and, honestly, the weirdest part of his famous table, the empty spaces.
Let's set the scene. It's 1869. Dmitri Mendeleev, a Russian chemist, is about to show the world something that will completely change how we think about the universe. But to most of the scientists in the room, it probably just looked like a first draft full of mistakes.
I mean, can you imagine the guts that took? He puts together this chart of all the elements known to man, but then just leaves these big, gaping holes in it. And these weren't mistakes, they weren't things he forgot. They were totally intentional. They were placeholders for the future. You do that. To get it, you have to understand the mission he was on. At the time, the world of chemistry was kind of a chaotic mess. He was convinced there was a hidden pattern, a secret logic to it all, and he was determined to find it. His method was actually beautiful in its simplicity. He started arranging all the elements by their atomic weight, and as he did, like magic, a pattern started to show up. Elements with similar vibes, similar properties, started lining up in regular intervals. He'd found a rhythm, a beat to the music of the universe. And then he hit a wall. As he kept going, his perfect, beautiful pattern would just break. An element just wouldn't fit where the pattern said it should. And this was the moment, the critical moment, where everything could have gone a completely different way. Where the story gets really good. Because what he did next wasn't just smart science, it was incredibly brave. It was a huge leap of faith. So he had a choice to make, right? He could take the safe path, just assume his pattern was wrong, fudge the numbers a bit, and force everything to fit. That's what most people would have done. But Mendeleev, he chose the genius path. He said, no, the pattern is right. Our knowledge is what's wrong. The problem wasn't his system. It was that we were missing pieces of the puzzle. And this is where it gets totally mind-blowing. He didn't just say, hey, I think something goes here. No way. He basically wrote up a scientific wanted poster for elements that no human had ever seen. And we're not talking vague guesses here. He got incredibly specific. He predicted their atomic mass, how dense they would be, and even their chemical behavior, like how they'd react with other elements. He was describing these scientific ghosts with just staggering confidence. And just look at how right he was. It's wild. He predicted an element he called Eka aluminum should have an atomic mass of about 68. Years later, they find gallium, its mass, 69.7. So close. Then he predicted Eka silicon with a mass of about 72. They discovered germanium, and its mass is 72.6. I mean, come on, that is unbelievably accurate. That brings us to the big payoff. For years, those blank spaces on his chart were just a wild theory, a bold claim. And then, science started to catch up to his vision. Just look at this timeline. He publishes his table in 1869. It then takes 6 years for the first proof to show up, and more than 15 years for the second. Can you imagine waiting that long to find out if your craziest idea was right, with the whole world watching? So first on the list was his prediction for Eka aluminum, the element that he says should exist right below aluminum on his chart. And then, in 1875, reality came knocking. A French chemist discovers gallium. And its properties? They were an almost perfect match for everything Mendeleev had predicted. Check. One prophecy fulfilled.
But one success could be a fluke, right? The scientific community was still watching, still a little skeptical. Next up was his other major prediction, the element he called Eka silicon. 11 years later, boom, 1886. Germanium is discovered in Germany. And once again, it was a dead ringer for his description. The gaps weren't just theories anymore. They were real. His system, his crazy idea, actually worked. This is already one of the all-time great stories in science. But to really, truly appreciate just how massive his achievement was, you have to remember what he was working without. Think about this for a second. Mendeleev did all of this without knowing what a proton was or an electron.
He had no idea about quantum theory, the very rules that explain why the periodic table works the way it does. He was basically describing the exact specifications of a car engine without knowing what a piston or a spark plug even was. He saw the entire blueprint without seeing a single one of the tiny parts that made it work. It's just incredible. So here's the bottom line. Mendeleev's table wasn't just a list. It was a map. It didn't just show chemists where they were. It showed them where they needed to go next. He didn't just organize chemistry. He literally wrote its future, and then just sat back and waited for the rest of science to catch up and fill in the blanks he'd already drawn.